Hello everyone, welcome back. In our previous videos, we understood about the binary trees, different traversal techniques used to visit all the nodes in binary trees using iterative and recursive approach. In this video, we will extend those traversal techniques to visit all the nodes of general tree. So let's start. Before going into the traversal strategies, let's see what is general tree. As you can see here, general tree means one parent node can have multiple number of or n number of children node. That is why it is called as a N-ary tree. Let's understand the traversal strategies used for N-ary trees. N-ary tree nodes are visited using depth first search DFS and breadth first search DFS. Let's understand the depth first search or DFS for N-ary tree. So depth first search means you start from one root node and then take one branch and go into that branch as deep as possible till you visit the last node of that branch, or you can say the leaf node of the branch. And once you reach the leaf node, basically you backtrack and check for other branches. Using that strategy, you backtrack and check for all the branches and visit all the nodes of DFS. So basically DFS means you pick up one branch, go as deep as possible, and then backtrack and check for the other branches. Now let's understand the breadth first search BFS for N-ary trees. So in the BFS, the tree is divided basically into the levels. So level 0 starting from root, and all the children nodes connected to the root nodes comes into the next level, which is level 1. And all the children nodes which are connected to the level 1 nodes comes into the next level, which is level 2. So the level 0 nodes are visited first, and then all the nodes in level 1 are visited, and then nodes in level 2 are visited, so on. So this is the BFS traversal strategy for N-ary tree. Let's understand the implementation of depth first search DFS for N-ary tree using recursive approach. Node of the N-ary tree can be represented using class structure like this. Int val is the data stored in a node. It can be anything like string, object, etc. based on the requirements. Node in N-ary tree can have multiple children nodes. That is why it is represented as a list here, where the references of the child nodes are stored. As we know, recursion helps to solve the big problem by dividing it into the smaller problems by calling the function recursively with small input, which leads to the base case when the recursion exits. For example, if we say traversing the N-ary tree with root 1 as a big problem, then it can be divided into the small problems like traversing the subtrees of the main trees with this highlighted nodes at the root, and then dividing further with subtrees with these nodes as a root till we reach the nodes where which nodes don't have any children, which is our base case. Right? When we visit the nodes when we don't have any other children nodes to visit, basically we reach to the base case of the recursion. So we can see that this problem can be easily solved with the recursion because it is aligning with the recursion approach, like dividing the big problem to the small problem. So if we implement this recursion like this function, you can see the DFS recursive function is getting called recursively for subtree with the child node as a root node, right? Every time it is getting called with the child node, and then that DFS recursive function becomes the basically the recursive function for the tree with that child node as a root node. So when it reaches to the node which don't have any child, so let's say it reaches to the node 6 which don't have any child, then it will not go into this for node because it does not have any child, and it will basically return, means that it will backtrack to the previous state or function call, right? So basically we came to our base case where our recursion exits and goes to the previous state or basically backtracks to the previous state. Let's understand this implementation using this tree as an example. We will pick up one of the branch and subtree in it to understand the recursive approach in this implementation. As we know, recursion uses the system stack. to maintain the order of function calls by adding each function call as an entry to the stack. And as a part of that entry, it contains different things like function arguments, the return address of the function after execution, etc. Now we want to traverse this tree with node 1 as a root, then we will call this DFS recursive function with node 1 as an argument. And that call will be basically added to the system stack. Now, if you look into the for loop of this method, right, you can observe that the DFS recursive is called for each child. What does that mean? It means that for this big tree with root 1 node, it is dividing that traversal into the traversal of subtree with the child node as a root, okay? And going as deep as possible till the base case. What is the base case? Base case basically the node which does not have any children node, because in that case it will not go into the for loop and return. For example, now in this for loop of the DFS recursive function with node 1, it will basically go to the first child, which is 2, and call the DFS recursive method. And then for the DFS recursive method with the node 2 as a root, it will go into this for loop for the children of the node 2, which is 6, 7, 8. And then call the DFS recursive for the first child, which is 6. Now 6 node does not have any children, so it will basically return or basically backtrack to the previous state, which is the function execution for DFS recursive with node 2 as an argument, this for loop. And in that for loop, then it will go for the next child, which is 7. We will then call the DFS recursive with the node 7. For node 7 also there are no children, so it will basically come back to the previous state, which is DFS recursive function execution with node 2 as a root. And in that for loop only, it will return. And then it will check for the next child, which is 8, and call the DFS recursive for the node 8. And for node 8 also there are no child, so it will come back again. Now the for loop for the node 2 is finished, so it will also basically backtrack. Backtrack means it will go to the previous function execution, which is DFS recursive with node 1 in that for loop, and then check for the next child, which is 3. Like that, recursively it will visit all the nodes of the N-ary tree. So this is the implementation of depth first search DFS for N-ary tree using recursive approach. Let's understand the implementation of depth first search DFS for N-ary tree using iterative approach. So as we know that in DFS we start from the root, pick up one branch and go till the leaf node. And once we visit the leaf node, we basically backtrack to the previous visited node and check for the other branches to visit till the leaf node. So you can observe that we need to store or maintain all the visited nodes so that we can backtrack to the previous visited nodes whenever we complete one branch to check for other branches. So to maintain this visited nodes and to be able to backtrack to the previous visited node, we need to use the stack. In a recursion, we use the system stack. In an iterative approach, we need to use our custom stack. And you can see that we have pushed the node 1 to the stack here. Let's understand the implementation. Till there is at least some node is there to traverse in a stack, we will continue. Till the stack is not empty, we will continue while loop. Now here we will pop from the stack, which is current node, which is 1, print some value, basically print the value of that node, whatever the value that node has or the data that node has, and check for all the children of that node. So what are the children of the node? Here is 2, 3, 4, 5. We will push the children of the node 1 in a previous order, 5, 4, 3, 2, because stack means that last in first out. So if you want to visit 2 first, we need to add it last to the stack while putting the children of the node 1. Now it will come back to the while loop again, the beginning of the while loop again. Stack is not empty, it will pop the stack, which is 2. The children of the 2 will be pushed to the stack, which is 8, 7, 6. Then it will basically pop the 6, and the children of the 6 does not have any children, so it will not push anything to the stack. So you can see we basically traversed one branch as deep as possible till the leaf node from root node. Now the 7 will also be popped. No children for 7, so nothing pushed to stack. Similarly for node 8. Node 3 also does not have any children, so it will be popped and nothing is pushed to the stack. For 4, it is popped and the 10 and 9 children are pushed to the stack. 9 is visited, then 10 is visited, 5 is visited, and none of them had any children, so nothing was pushed to the stack. Now stack is empty, so we will come out of the loop. And you can see all the nodes of the N-ary tree are visited using DFS iterative approach. So this is the implementation of DFS iterative approach for N-ary tree. Now let's understand the breadth first search implementation for N-ary tree using queue. Now why queue? Because we know that DFS means visiting the nodes level by level. So the node which comes to the early level gets visited first. So we can see the FIFO property here, right? And that can be achieved using queue data structure. That's why we are using queue. Now we declared one queue and we push the, or basically enqueued node 1 to the queue. Till there are some, there is a queue is not empty, it means that we have some node to traverse. We will continue this while loop. Now queue is node 1 is dequeued from the queue. All the children of that node 1, which are 2, 3, 4, 5, are pushed to the queue. See, in a DFS and BFS, the order in which we want to push to the queue and stack, it depends on the problem statement. Here we are pushing to keep the traversal order same in all the examples. That's why, but it can be pushed. Like here, you can push 5, 4, 3, 2 also, depending on to the problem statement you are solving. Now the node 2 will be dequeued because first in first out, all the children of the node 2 are enqueued to the queue. Then node 3 is visited, no children, so nothing is added. It will come back to the beginning of the while loop again. Node 4 is dequeued, all the children are added, 9, 10. Node 5 is dequeued, no children, 6, 7, 8. They don't have any children, so they will be dequeued one by one and nothing will be enqueued to the queue. Now all the nodes are visited and queue is empty. It means that we completed our traversal. So you can see that using queue data structure, we completed the traversal of N-ary tree used as a BFS approach. In this video, we understood about the general tree and we also understood about how the depth first search and breadth first search techniques can be extended to the N-ary tree. And we then understood the implementation of these traversal techniques for N-ary tree using recursive and iterative approach for DFS and using queue for BFS. Hope you understood the explanation. If you like the video, please share and subscribe. Thank you so much.